Hello, today I am going to discuss about the PLC internal memory application concept for Allen Bradley or Rowell Automation RSLogix 500. So let me create a new file. So I need to close this current file. So I need to click this and go offline. Then maybe I save the changes. Okay, then I close this one and then I click new. Then I select this one. You can select any other option if you want. Make sure the driver is emulator 500. Click OK. Alright, so I click this one. Then I will create a new run. Okay, so for example, maybe usually what we do is for the PLC ladder logic programming is we'll put in some instruction and then we'll put in the virtual output coil. For example, maybe we'll put this normally open virtual switch instruction. Sorry. Okay. And then maybe for the basic circuit, maybe you put another one virtual output coil here. So usually what we do is we'll type in the addressing, maybe digital input. Okay, column, maybe slot 0. Okay, slash bit number, maybe I use a bit 0 or 0 terminal point. Let's say this is a switch. Okay, 0. And then this one, for example, digital output column. Okay, slot 0 slash the bit, maybe I use bit 0 or terminal point 0. Maybe the description I will put maybe lamp 0. Okay, so maybe maybe I put one more. Maybe I put this normally closed virtual switch here and then another virtual output coil here. Maybe this one I will put digital input column slot 0 slash bit 1. Maybe this one I put switch 1. Okay, this one I can just copy down, click this instruction, hold the control key and drag to here. This one I can click and delete. So I want to change the addressing, so I just need to hover above the addressing number here, or I just need to hover on the black highlight and double click. Okay, then you can change the addressing. Let's say I use big one, then maybe the description is a lamp one. All right. Okay, so usually what we did is for this simple circuit, it was switch on the external switch, and then once we switch on the external switch, which is for example normally open, so the current will flow through the circuit to energize the digital input 0 or terminal point 0, and this will cause the virtual switch to trigger from normally open to close. For this one, then the virtual power will flow through here to energize the virtual output coil. So this will cause the digital output internal normally open switch to trigger to close, and then the current can flow through this digital output circuit and then will activate the external load such as lighting, such as buzzer or contactor or relay, etc. Okay, so as for the, for example, we have another switch one. Okay, so this switch one is for example, maybe it's a normally open. So when we press, what happens, the current will flow through the circuit, external circuit, to the PLC physical digital input terminal point 1. Okay, and this will energize the is a digital input 1 LED, internal LED, and this will cause the relevant virtual switch to trigger from normally closed to open. Because of this, the virtual power cannot flow through this rung to energize the virtual output coil. Okay, so if the digital input switch 1, physical switch 1, which located outside the PLC circuit, which is not visible here because I do not have the physical PLC. If we do not push the switch on, the external switch to on, so there's no current to energize the physical digital input switch 1. Hence, this virtual switch normally closed will remain closed, and the virtual power can flow through and then will energize this virtual output coil 1, and thus will cause the digital output 1 internal normally open switch to trigger to close. Hence, the current can flow through this digital output 1 circuit, and it will activate the external load such as the contactor, relay, buzzer, etc. Okay, so let me maybe create a new rung to explain so that it will be easier to understand. Instead of using this uh, virtual output coil, which will waste our physical digital output terminal point also. So in order to save the digital input terminal point as well as the digital output terminal points, we can use the memory. The memory can be the binary, can be timer control counter integer float. Okay, for today's case, I plan to make the sharing easier, so I will use the binary only. So this binary data file is a kind of bit, either 1 or 0, on or off. Okay, it's a very simple concept. It's similar to the digital input and the digital output. Okay, so let's say I put here. Okay, all right, so I maybe create another circuit. Sorry. Okay, maybe I put this one, virtual switch, normally open virtual switch, and then normally close virtual switch here. Okay, so this one I will put the virtual output coil. I click this one, hold down the control key, and then drag here to copy it. Okay, this one maybe I can use this binary. So this binary, let's say I use this binary 3. Okay, this is B stand for binary, 3 is a file type, B binary is a file name, 3 is a file type, and then colon 0. 0 is a word 0. One word consists of 16 bit. Counting from bit 0 to bit 1 to bit 2 till bit 15. Total got 16 bits. Alright, so if you want more binary elements, you click the property, and then at the element you can change. Let's say you want 5, click OK, then you got 5. Okay, 5 binary words from word 0 to word 1 to word 4. Okay, so alright, so for this one, let's say I want to use this. Maybe if I will use the bit 0 of this B3 column 0. Okay, maybe description, I double click, I just write maybe memory 0. I click OK. Maybe later I will use this one, bit 1 of this B3 colon 0. So I double click the description, I put some command or description. Maybe I will put memory 1. Okay, so I click this and I drag to here. Sorry, click this, I drag to here, and then I click this one, then I drag to here. Okay, and then this one we also can use a binary to store the bit status. either 1 or 0. Okay, so it's very easy. Maybe I use bit 2. Maybe the description I will put output memory. Okay, maybe I put output memory 2. Okay, this one maybe I put output memory 3. Okay, so I click this bit 2 and then drag to here, and then I will click this bit 3 and then I drag to here. Okay, so maybe I create another rung so that easier to understand. Okay, how about maybe I create one more rung. Okay, maybe this one I will put this switch, and then maybe this switch. Sorry, this one I delete, and then maybe I create another instruction. I copy it. So what I need to do, I hold down the control key and then I drag it. Okay, click this one, hold down the control key and I drag here. Okay, okay, maybe this one I use bit 0, 2, lamp 2, and then lamp 3. Okay, all right. Okay, so now what I need to do is first I will compile it. So now they got error to say that this rung number 4 and number 5 operand not enter. That means you do not enter the addressing. So the addressing maybe is this one. So I click the addressing number, then I just drag down, press the control key to copy over. Then I click this one, the black highlight of the addressing number, then hold down the control key and then I drag to here. Okay, now verify the project one more time. Verify the file, verify project, and there's no error. Okay, so now what I need to do, first thing we need to do is we save the file. Okay, we can save into our computer or laptop directory. Okay, you can save to any directory that you want. Maybe I just give a file name. Maybe I say memory application. Okay, you can give a name to your processor. Okay, if you don't want to give a name, it's okay, you just leave the name untitled. Okay, maybe I give a name virtual PLC, maybe 3. Okay, you can give any name, so click save. Okay, then after that you have to go to emulate 500. All right, go to emulate 500, open the file that you saved just now. Okay, click. So don't have. So what you need to do is you have to save one more time. Okay, then go to emulate 500, click the file that you saved just now, click memory application that I saved just now, open it. Okay, I have used the station number 012, so I cannot use the same number again, but I can use other number. Let's say I use number 3. Okay, then after that you can either click this down arrow key, okay, and then click download, or you can click communication, system communication, and then click the processor means the PLC that we saved just now, we created just now, or we saved just now. Alright, then click this one and download. Or you can click this, then click download, and then click OK. Then it will tell you it will download this software from the laptop into the emulate 500 virtual PLC. Okay, since we do not have the physical PLC, so we use a virtual PLC. Then click yes, click yes to go online. Then make sure to click this one and click run so that it can run the PLC program. Alright, okay, you can see now this virtual switch is normally closed. Okay, so it is not triggered to open yet. So what happened is the virtual power can go through this normally closed instruction or virtual switch and then energize the virtual output coil. Then the lamp one will turn on, right? Similarly for this memory one, where it is a virtual switch also. It is a normally closed virtual switch and it is not triggered. So the normally closed remain closed. The virtual power can flow through this run and then energize this output memory tree, okay, which is a binary memory. And this is related, is linked to this. You see B303, B3 colon 0 slash 3 is linked together. So it will trigger this normally open virtual switch from normally open to close. How we know it's closed? You can see the green highlight. The green highlight means the instruction is closed. Just like this one. The green highlight means the instruction is closed. This one also. So it can be the normally closed remain closed instruction or the normally open instruction trigger to close. As long as there's a green highlight, it means this instruction state is closed. Okay, so because it is triggered from normally open to close, then the virtual power can flow through this run and then energize this output coil, virtual output coil. Thus will turn on the lamp 3. Okay, so what happened is if I trigger this to close, this lamp will be energized and turn on the lamp 0, right? If I trigger this by clicking the toggle bit, okay, this virtual switch will trigger from normally closed to open, hence no virtual power to energize this lamp 1. Hence this lamp 1 will be turned off. Similarly for the memory here, okay, so if this memory 0, okay, is triggered from normally open to close by clicking the toggle bit, it will cause the virtual power to flow through this run to energize this binary memory, okay, and cause the output memory to be energized, and this will cause this output memory to virtual switch to be triggered from normally open to close, and then the virtual power will flow through the run to energize this digital output 2 and cause the lamp 2 to turn on. Similarly, if this memory 1 is triggered from normally close to open by clicking the toggle bit, this will be open and hence no virtual power to energize this memory tree, and thus will cause the memory tree state remain open, normally open remain open, and then there's no virtual power and this lamp tree will remain off. Okay, so now let's say I click here and then I right click, I toggle bit. What happened? This will trigger. Okay, similarly for this memory 0, I click here, I right click, I toggle bit. You see this will be energized, and this output memory 2 will cause this the virtual switch is relevant virtual switch to be triggered from normally open to close. Thus will turn on the lamp, energize the digital output 2 and turn on the lamp, right? So what happened is for this switch 1, if I trigger to open from normally closed state, you see there's no virtual power to energize the digital output 1, thus the lamp 1 will not be turned on. Similarly for this memory 1, if I trigger it to open from normally closed state, what happened? This output memory tree will not be energized, thus its relevant output memory tree virtual switch will not be triggered. That means normally open remain open. Okay, and then there's no virtual power to this rung. Of course, it will not energize this digital output tree, and it will not turn on the lamp tree. Okay, that's all. Thank you.